Yeah, today we're going to talk about object-oriented programming in JavaScript. It was supposed to be a 1 hour lecture. We already are 35 minutes in. So I think this is going to take another hour. I will try to contain myself. Usually when I speak for too long, for hours and hours. Some of you will know it from my personal channel. So I'm going to try to cut it relatively short. This is the first video. This is the first live broadcast of a series of lectures on programming with JavaScript. Now, Coyotiv is offering a school of software engineering in full-time, part-time, and self-paced modes. So you can study with us at your convenient time, and however much time you can dedicate over 2 months, over 6 months, over a year, you can study with us and learn programming with JavaScript and learn software engineering fundamentals with JavaScript. We teach full stack JavaScript with Node.js on the backend, Vue.js on the front end, MongoDB as our database. But we don't only teach you how to code, because everybody can code. We want you to become a real software engineer. We want you to differentiate from the many other coders out there. When you join a company, you should be differentiating with your knowledge. And your team should look up to you with your for your expertise and for your understanding of how software should work. Now, what we teach you is the fundamentals and the thinking and the methodology behind software engineering, the philosophy of software engineering, and not just coding. Everybody can code, but only those ones who trained in understanding and evaluating and appreciating better code can become real software engineers. So that's why we don't call it a bootcamp, because a bootcamp doesn't teach you UML diagrams. A bootcamp doesn't teach you architecture. A bootcamp doesn't teach you event-driven architecture or GUI architectures or second or third level information or knowledge about object-oriented design, solid principles, and deployment with Docker, and how to build your own Docker file, and how to build your own cloud in Google Cloud. These are the stuff that we cover in Coyotiv's Closed Software Engineering. So we wanted to do these public lectures to give you kind of a sneak peek at what we're doing at Coyotiv and how our lectures are. We have about 110 hours of lectures in Coyotiv's Closed Software Engineering program. So if we do it an hour a week, it's going to take approximately 2 years to finish the course on YouTube. So we wanted to offer you some selected topics from our curriculum that we're doing at Coyotiv's Closed Software Engineering, so that you can get a taste of what we're doing. And I myself am very active in open source and in communities, and I've been helping out communities for more than 5 years now, actively training people, hundreds of them at a time, and helping them enter the software industry. So I thought, let's give it a new home. Let's do these over YouTube in this channel, at Coyotiv's channel, and let's talk about the aspects of programming that really matters. The other stuff, the syntax, the how to build a project, how to use TypeScript, how to use Vue.js, what is Vuex. You can read about these things and look at the tutorials that are already out there, and it would be okay. I mean, you would understand the syntax, you'd understand how you're supposed to use them, but knowing how the professionals use those and knowing why the teams that came up with Vue.js, for example, came up with that syntax? What are they aiming at? What is the best way to write a certain piece of code? Those things are hard to teach, and we believe you will learn them best alongside a master, because this is, in the end, apprenticeship. Software is a craft, and software development is craftspersonship. So I think you're hearing the sirens in the background. I know it's a little bit disturbing, but please bear with me. And in the end, unless you work with a real master who knows what they're doing, and unfortunately most of the people in the industry don't know what they're doing, you don't learn these things. And this is why we wanted to do these series, do these public lectures, because I want to publicly talk about the best way to think about software, to build software. And I want to leave a resource that everybody can look back and enjoy, where we discuss the philosophy of software engineering, modern software engineering. And we're going to be talking about these concepts in the context of JavaScript and JavaScript technologies. Now, obviously, it's not the only language in the world. It's not even my favorite language. I think my favorite language is CSS, and my favorite general purpose language is Swift. But I love JavaScript as well. And I'm using JavaScript because it's widely available and you can do everything with it. And I have done quite a bit on JavaScript. You can look at my personal channel, look at my public talks. I have a playlist for that, and my GitHub. It's full of projects that I did with JavaScript that range from brain signal processing to cloud architectures and so on. So this is why we will be talking about JavaScript, because it's ubiquitous. It's available everywhere. And it's like, this term is not mine, of course, somebody came up with it, but it's like lingua franca of the web. It is the language of the web. So it will be great for you to know JavaScript and know software engineering and how that applies to JavaScript in particular. Today's topic is about object-oriented programming. And I wanted to give you an example of a taxi booking app like Uber, and talk about the concepts that I'm going to talk about over that example. But now I'm thinking maybe we should switch to, I don't know, a fire brigade putting out a fire. That would be really thematic, like with today's topic. And I don't know, that could work as well. We will see. All right. Today I'm going to be writing some code. I'm going to be showing you the principles that I'm talking about. But before we get to that part, let's talk a little bit about object-oriented programming itself. This is still a 1-hour lecture, so we won't be able to go very deep into how we cover object-oriented programming at Coyotiv, but I'm going to give you some of the very basics. I always ask my students to ask questions, especially what-if questions. And maybe the first question that you should ask when you think of object-oriented programming is, why does this thing exist? Why? Why did they want to create a convention where people wanted to create objects and their relationships and use them? And yeah, this video will be on the channel Umut after the broadcast. So the question is, why do we use objects? And the answer to that is very simple. It's a lot simpler than you'd ever think. The answer is, we are a social species, and what we do best is to create connections. We are human beings. We create connections to each other. We're like, we have a family, we have friends, we have our tools that we make, that we build, and with those tools we created thousands of civilizations. This is natural to us. Objects and their relationships are natural to us. Now, there are also other species in the world which use objects, and I'm terrible at biology, so I don't know what those are. I think apes use some tools. I think even I don't know, crows use some tools. So other animals too, they are capable of using tools, but it's very limited. Their use is very limited, and they are currently not at this stage of where they bring those tools together to make something more complex. And then they would bring those complex tools together to make yet more complex items, more complex tools. And that's how they grow their societies, right? Even though some animals are living in packs, like wolves or, again, chimpanzees or other animals, otters, do otters use tools? Maybe. I'm terrible with biology. I mean, even if you said like jellyfish, I would be, yeah, I think they use tools. So this is very, very natural to us. Everything around us are objects, and we are somewhat related to them. We can explain those relations. We have a lot of language to explain those relations. Like, I don't know, I have a cup and I drink from that cup. I love that cup because of its shape. And I heat that cup up when it has coffee in it, or when it has cream in it. You can even bake a cake in a cup. See, I told you I got a new microwave. I'm learning how to bake cakes in a microwave. And apparently it's possible to bake a cake in a cup, in a mug. Mugs, we also use them as awards or as gifts to remember each other. You know, this is something we did a while back. We had a course with Women Tech Makers Berlin, and we gifted mugs to the graduates that says on them, "Don't be afraid to fail. Be afraid not to try," something like that. That was a good memory. So mugs even serve us to remind us of certain events that we loved in the past. Now, why do we need to express software this way, though, in terms of objects and their relationships? I told you it's natural, but do we have to use it as it is? Does it have to really be that natural? And at first, it didn't have to be. At first, the use of computers were really limited. Like, why would you use a computer? You would calculate the trajectory of a space rocket. You would do some mathematical calculations. You would do some encryption for the military. That's actually how a lot of this technology was developed for. They developed it for the military. And back then, mathematicians were on programming. And they were working a lot with mathematical models and so on. So they didn't really need to express themselves in natural objects. But when it comes to the 70s and the 80s, where computers and programming are becoming more and more common, and people find out that they can actually use computers for a lot more than what they're capable of. They can write software for banking. They can write software for inventory management, for salary management, people management, project management. They can write word processors so they can build documents in software instead of a typewriter. You know, people were like, we have a typewriter. Why would we need a computer to write a document out? I'm much faster with my typewriter. And fast forward 50 years, and now we have, you know, amazing word processors in our computers, in our phones even. So the uses basically grew exponentially. And writing software became much harder because A, the number of lines you have to write is much, much, much more. And B, the concepts that you're dealing with are the concepts from real life. It's not rocket science, literally. You're not dealing with rocket science when you're writing code anymore. You're dealing with bank accounts, you're dealing with people, you're dealing with accounts, you're dealing with users and their preferences and their documents and, I don't know, their employees, their salaries, their departments. So these concepts are taken from our life, our real life, right? Now, what is a computer programmer supposed to do? Somebody comes up to you and asks you to build an app for taxi booking, for car sharing. How do you program that? It is possible to program it as a series of mathematical functions, of course. But that would be really difficult to understand, to comprehend, and to keep track of every single function, every single equation in your head. Remember college years when your math professor filled walls and walls of whiteboards or blackboards with formulas and their solutions. This would work, but it would be really difficult for A, multiple people to collaborate on, and B, for those developers to talk to the business people and understand their requirements. You know, when a business person tells you that they want to be able to book a taxi, what does that mean? What is a taxi? Is it a set of equations in your code? Or is it something that you can directly relate to called a taxi? What is the booking action? Is it a series of formulas and equations in your code? Or is it just that? A function called book, where a user books a taxi. Now, this is why people felt the need to come up with, oh wow, Alina, are you, is that real? Wow. Okay, I'm now very, very honored. Wow, this is great news. Amazing. I'm so happy. Okay, great. Yes, we made it. Alina is one of our students from our first cohort. Yeah, I'm very happy. Whew, wow, this is great. This is great. Congratulations. Alina is one of our students from our first ever cohort at Coyotiv. You know, the special bunch. She's one of the special people. And I think we what time did we end the course? Like 2 weeks ago? I think it was 2 weeks ago, right? Maybe 3 weeks ago. probably 3 weeks ago. And I'm very happy that most of our students by now found their jobs. Actually, a significant portion of our students found jobs before they graduated. And then everyone else is just following up. Amazing. Thank you, Alina. Yeah. Maybe let's not go too much extreme. But I'm very proud of you and your achievements. I want to look at the offer. I know you're gonna write it to the alumni channel. I'm looking forward to seeing the company, the offer, the position. I'm very happy. I'm very happy. Congratulations in your new career. Amazing. This is great. What was I talking about? I was saying object-oriented programming, right? These concepts are natural to us, and it would be best if you can express your software in these terms. If you can have an entity called a car, an entity called a driver, or an entity called a vehicle, because you might have multiple vehicles, and a driver, and a customer, and a booking. If these are the entities in your code, and if the actions are like book, cancel, reroute, navigate, for example, or look up address or something, or yeah, locations, of course, also. These are very natural to us because we can understand them. They exist in real life. Why should we complicate it more? The job is to make things much simpler. Don't forget, the responsibility of a software engineer is not to overcomplicate things. The responsibility of a software engineer is to solve problems. When you solve a problem by creating code, you're creating another problem. The best solution involves zero code. Nobody likes to deal with code that they don't understand. I'm talking about like founders and business people. They don't want to deal with code they don't understand. They always need a software engineer, a wizard, a whiz kid to tell them what to do with their code. And it sucks. Believe me, I've been on that side of the table. It sucks. So your job as a responsible software engineer is to solve that complexity, is to reduce that complexity. If your business counterpart can look at the code that you write and can kind of understand what's going on, can kind of understand the flow, then that is perfect. Then that is what you're looking for. Then you're successful. Now, I hope I'm making a point here, and I would love to have some reactions from you in the chat if I make sense, if you like the content, if I'm boring or not. I would love to hear your comments in the chat. I'm constantly monitoring them. But this is why object-oriented programming came to be. Now, if you are all right about why it came to be in the first place, then we can talk about how to do proper object-oriented design. The first rule of proper object-oriented design is that it should be natural. You should think naturally. And yes, because we're humans, you should think naturally. This is the condition of object-oriented programming. A lot of times when I review code, I see designs that could reflect how the process works in real life, but for some reason doesn't. I'm like, why did you need to program it this way? There should be a simpler way of doing this. And when I say you should think naturally, I mean you should think in terms of objects, their behavior, and their state. So let's think about an object. In our car booking, our taxi booking app, our Uber clone. There's a taxi, right? That's an object. Other objects could be, as I told you before, it could be a location, it could be a booking, it could be a customer. The customers can see their booking history, so it could also probably be there could also be a booking history class that is that holds an array of bookings basically for a customer. These are real objects that you can interact with. There are locations. They are real objects. You can look them up on the map. And there's a trip. The trip that you're taking is different than a booking. A booking is a trip. A trip has to have a booking. You cannot just take a cab without booking one, right? There has to be a booking first. So for trip to exist, there has to be a booking. First, you create the booking, and then you say, I want to go, you declare your intent. I want to go from here to there. And then if everything goes right and you can get in the car, and if you like the conditions in the car, you ask the driver to drive, and then the trip begins. Until that time, you can cancel it. You can cancel the trip. So a booking doesn't have to have a trip. A booking might have 0 trips because you just canceled it. You didn't like it. This is very natural, right? Now we're going to see ways to express these in software. And I hope by the end of these lectures, you're going to be like, is this really object-oriented programming? Are you sure? Because this is something I can totally understand, and I can totally express myself as well. And the answer is, of course, yes. This is object-oriented programming. And anything else you find on the internet are complications on top that might be useful sometimes, but are not always necessary. And most of them are missing the essence of object-oriented programming. Let's go back to our example. We have a taxi that you can book, right? That's an object. What are its behaviors? What can a taxi do? For example, can a taxi book itself or another taxi? No. A taxi can drive from one location to another one, or can go from one location to another one. A taxi can stop, or a taxi can go out of service. These are its behaviors. It can pick up customers. It can drop off customers. Right now, I'm not making a distinction between a driver and a taxi, and I'm thinking that, let's, for this parenthesis, this example, let's think the year is 2040 and there are no drivers. All the cabs are autonomous. So the cab goes from place A to place B, and it picks person A, and then it drives to person A's destination, and it drops off person A there. These are its behaviors, right? These are the methods of a taxi. A taxi can pick up a customer, can drop off a customer at a certain location. Do I make sense? And when I ask this, please let me know in the comment below whether I make sense or not. So, and also please let me know if you have other examples of behaviors for a taxi. The next topic that we need to talk about objects is their state, because an object is a collection of behavior and state. So taxi behavior, pick up, drop off, drive, whatever. What are its states? Now, it can be functional, that it's on and in service. It can be in service or out of service. It might be available for a booking and not available for a booking. It might be hosting a customer right now or not. So there might be someone in the taxi or not. It might have its speed. It might have its destination, where it's coming from and where it's going. It might have its color, yes, although the color would be kind of irrelevant for our taxi booking application. It might have a type. This is very common in Uber. When you book Uber, you can pick between a taxi, a normal person who doesn't have a taxi license, which is illegal in pretty much every country, or you can have luxury cars, large cars, or vans even that can accommodate more people. So this would be a type of a taxi. So these are its states, right? And depending on certain conditions, its states can change. Like a taxi, again, can go out of service at night or out of their shift. Oh yeah, they might have shifts and working schedules, for example. And when you book a taxi, it's not available for booking anymore. It was, somebody booked it, now it's unavailable for another booking until that booking is over. And remember, that booking may or may not include a trip. So these are the states of a taxi. And either the taxi itself or another entity, like a customer, can change these states. For example, it's a real life scenario, right? You have a taxi booking, you're going from somewhere to somewhere else, and you just recognize, and this happened yesterday, you just recognize that you forget something, and you immediately stop the car. You say, please stop, I need to go back, and I need to pick something up. So a customer can actually stop a taxi. A taxi has directions that it's following, for like navigational directions, and a passenger, a user, might indicate their preference in these directions. They can say, don't take that road, please, that's very crowded, or I want to just go by the seaside. This is something I do a lot when I go to Istanbul and land, and when I'm getting home by a taxi, I like, should we go by the sea or should we go outside the sea in the autobahn? And I'm like, by the sea is great. Let's I miss sea. Let me see some sea, and then I enjoy the sea from Pendik to Kadıköy. So you can indicate your preference of a route, which means you can change the state and the future state of a taxi. A passenger can change the state and the future state of a taxi. How would this work? You would tell the driver, in this case, there are no drivers because the year is 2040 and all cars are autonomous. You tell the car, please take the seaside road, and then it does so instead of the highway. So you tell, or you ask basically the car to do something for you, and it does. But fundamentally, at the end, you can change its state. You can affect its behavior. Now, object-oriented programming is all about this. Objects, their behavior, their states, and the relationships in between them. Hello, Yukai. How are you? Long time no see. And this is basically all. This is everything about object-oriented programming. If you can express these real-life objects and their relationships in detail, as in, again, the example of a booking and a trip. A booking may or may not have a trip. And a trip would not exist without a booking, right? A trip would not exist without a booking. And when a booking ends, a trip must also end. This is a very strong relationship between a booking and a trip. We call this a composition relationship. This is really important. This is going to come up in the future lectures. We call this a composition relationship. But no such strong relationship is present between a passenger and a taxi. A passenger was there before the taxi, will be there after the taxi. A taxi was there before the passenger, and hopefully it will be there after the passenger. They're going to continue their separate lives. Just, in the course of their lifetime, for a simple duration, they are together. The taxi and the passenger are together for a small duration in their entire lifetimes. So this is a very weak association. This is a very weak relationship, and we call this, you might have guessed, association. So there are the other concepts in object-oriented programming are what we call implementation details. They might change from one language to the other. They might change from one paradigm to the other. They might change from one programmer to the other. But the fundamentals are you have objects, they have relationships, and they have behavior and state. Okay, now this is a great intro, and we have about 20 minutes left, and I'm gonna start writing code, and I'm gonna try to code this example in JavaScript. Before we get to that part, please let me know if you have any questions, if I'm missing anything, if there are anything that you want me to talk more about. Of course, this public lecture series is for people who are very new to programming, and we are just introducing programming. It's for people who have zero experience with JavaScript. But this is the strongest feature aspect of our school. The topics that we're talking about, object-oriented programming, it is a tough one. It's not even CS 101. You don't learn about these things in CS 101. Maybe 201, maybe. Nobody starts with object-oriented programming. Every school starts with imperative programming. And that's okay if that works for them. But I think what works best for us and our students is to know the modern programming methodologies as simple as we can get them and as simple as they can learn them. So we're talking about object-oriented programming. That is the first class ever of Coyotiv as well. JS 101 is the first class that we have on the first day, and we cover these topics there. And we immediately start with object-oriented programming. So if you can understand the concepts, the syntax is just some details. You can look them up. You can learn them. Doesn't really matter. So therefore, I'm taking it kind of slowly, but also surely, and hopefully you're going to make sure that you internalize all the fundamentals and philosophy of object-oriented programming, and then the rest is just practice. You need to practice a lot, and I hope the content will equally apply to junior, mid-level, or senior engineers as well, because I think it's a long lost fresh perspective. When we learn about object-oriented programming, nobody teaches us the background, why we're doing it, why it is so ubiquitous, so widely accepted. People are talking about concepts like classes, interfaces, and inheritance, and polymorphism, and so on and so forth. These are all great concepts, but the fundamental thing is that the inspiration comes from nature. You should not overcomplicate any of these interactions. A user should be able to book a taxi, and the taxi doesn't book itself. A user books a taxi, and when the user enters the taxi, then the user becomes a passenger. A trip has a passenger. A taxi has a passenger, but that's a user. So these concepts are, really, really natural. They draw their inspiration from nature. And if you look around, you're going to see that you can model everything around you in terms of object-oriented code. And this is going to be the exercise for today, for you. After watching this video, try this at home. Look at something around you and try to program that. Try to program those interactions, those objects, their behaviors, their relationships. Like a laptop, that's an object. You are a programmer. You are an object. How do you relate to the laptop? How do you work with the laptop? What functions does the laptop have? What are the states of the laptop? Can you change those states with your actions? Very easy. Very, very easy. And this is basically what enterprise programming is as well. This is the last thing that I'm going to tell before we dive into code. I'm telling you that this thing came up in the 80s, this notion of object-oriented programming. And at first, everything was great. And it was like, everybody was like, this is amazing. I now feel like a very productive programmer because I can actually understand what my code is doing, because I can relate to it. And then people diverged from this so far. They built more and more and more complex topics, ideas, implementations, practices, patterns on top, that they kind of missed the point of being natural. And by late 90s, the code that we were writing, it wasn't natural at all. It was far from natural. It was too complicated. And we called it enterprise software. And then some amazing, brilliant people came up and reminded us that programming, object-oriented programming, supposed to be natural. And they introduced a concept called domain-driven design. It was just a recital of the original principles of object-oriented programming, because everybody forgot. In that time frame, everybody forgot, and they needed to be reminded. So it's now the most known books of all time, domain-driven design. It's still valid. It's still amazing. And its premise is really simple. Come up with a ubiquitous language. Come up with a... Thank you, Savash. Come up with a language, a set of names that we can all understand and agree upon and use them and come up with groups of objects. Group your objects and classes after business concerns. That's very simple. That's what object-oriented programming is, right? But a lot of people just forgot, and they need to be reminded. This is why we're opening the lecture series with object-oriented programming. It is very simple. There's nothing to be afraid of. It's not a complex topic at all. You don't need to complicate it. If you just keep these things in your mind, it's gonna be fine. You're gonna be fine. All right, now I'm gonna share my screen and Mehmet Ali Özer, are you sleeping? Am I boring? Is that the case? Is that what's happening here? Are you sleeping? I hope I'm not. Okay, now let me share my screen with you. All right, I hope you can see my screen now. Now, you see my IDE, Visual Studio Code. It's not even a node project. It's an empty folder with an empty index.js file. Where are the colorful lights? Here in the back. I might switch to this. Yeah, the colorful lights are in the back. I have 2 shades. That should remind you of something. You know, I did all of this setup. I set up everything, my computer, my microphone, my lights, my camera, the lights in the background. There are 2 lights because I wanted to create the scene, and then the building went on fire. Crazy. But we're here together. And now let's go back and code a little bit. All right, I have an empty index.js file. This is a JavaScript file. I'm going to be able to run it later. First, let me write a couple of things. Now, object-oriented programming with JavaScript starts with objects, of course. And we will assign these objects to variables so that we can remember them, so that we can talk about them in the future. Now, the first variable that I'm going to introduce will be a taxi. Okay? And it will be equal to an object. This is how we denote an object in JavaScript, with curly brackets. It's going to have a state. Let's say driving. And currently it is stopped. It's not driving. So driving equals false. And then it should have 2 different behaviors: start driving and stop driving. Start driving is a function, and stop driving is another function. Okay? I think you can imagine what these a bike object, which is a behavior to burn, and force Armağan object to get downstairs. Yes, exactly. But that would be too cynical, and I don't want to do that. But yeah, exactly. That's what happened. My life. All right. You can imagine when you start driving, this should set driving to true. When you stop driving, this should set driving to false, right? And then there should be a passenger. Named Armağan. And there should be a location named Coyotiv. There should be a destination named Mitte. All right, I'm a passenger. I have a location and I want to go somewhere. A passenger should be able to book a taxi, right? And then what should that do? They should be able to tell the taxi to go to their destination. So probably, maybe, let's say, taxi navigate from, well, let's say navigate to a destination. So obviously the syntax is looking very weird to you right now. What I did is I created a taxi object that has state and that has behavior. Yeah, taxi takes some money. Yeah. And the passenger has some state, name, location, and destination. These can change. And they have a behavior. They can book a taxi. And when they book a taxi, they tell the taxi to navigate to their destination. Does the taxi know how to navigate right now? No. So the taxi should probably also have a location, right? Currently, somewhere, I don't know, anywhere. It's empty. They're in the void right now. So when you book a taxi, you first ask the taxi to navigate to your location. And then you ask a taxi to navigate to your destination. And then your booking ends. So what does the navigate to method do? It could probably set its location, start driving and stop driving as well. So what it should do is, let's think naturally, you are the taxi. You need to navigate from some place to another. You need a destination, right? You need to navigate from some place to another. What you do is you first start the engine. You first start driving. Unless you start driving, you're not gonna go to your destination. You start driving and then your location changes, becomes a destination, and then you stop driving. Do I make sense? We have a passenger who can book a taxi. We have a taxi who can start driving, stop driving, and navigate to a destination. So we first ask the taxi to navigate to our location because it's going to pick us up. And then we ask the taxi to navigate to the destination. Let's also say enter vehicle and exit vehicle. A passenger can enter a vehicle and exit a vehicle, right? So enter taxi. Let's call taxi instead of a vehicle. and leave taxi. What should this do? When you enter a taxi, you are the taxi's passenger, right? You become the taxi's passenger. So I would say taxi.passenger would be this. Arba, I think you cannot book a taxi unless it's available. So I kind of glossed over that detail. And when you leave a taxi, what you do is taxi.passenger equals null. Null means nothing is there. There's no value. The passenger, there's no passenger in the taxi. So of course, this is another state for the taxi, right? Whether it has a passenger or not. Currently, it doesn't have a passenger. But if a passenger enters a taxi, then taxi has that person as a passenger. And maybe let's call this a person and not a passenger yet, because not everybody is a passenger or a user. Could be that as well. Or a customer. Let's call this a customer. Makes more sense. So when you book a taxi, the taxi first comes to you, and then you enter the taxi, right? Then you navigate to the destination, and then you exit the taxi. You leave the taxi because you are already in your destination. And here, what happens is you also update your location. This location becomes this destination. Or better yet, this location becomes taxi.location. You are where the taxi took you. It's very simple. At the end of the booking, you are where the taxi is. Your location equals to the taxi's location. And then you leave the taxi. Otherwise, you're like, this is not the right place, take me home, and so on. And I skipped payment here because, for example, in Uber, there is no payment. We're trying to model Uber. There's no payment. How would you use this? It would be as simple as customer booking a taxi, and that's all. Customer is booking a taxi. Now, let's see if this code works. Let's run this with a tool called NodeMon. It's probably running. Let's log the customer and see what's inside. There you go. Name, Armağan, location, Mitte. And yeah, when we change our location, maybe our destination should also clear. We don't have a destination anymore. This sounds interesting. Let's log the taxi. Currently not driving, and the location is Mitte, there is no passengers. Do we know if this is working? Now, I'm getting ahead of myself here, but I'm going to show you debugging this in real time and see how this software is working. So I will go to the debug menu, and I will create a launch.json file with Node.js here. And I will try to investigate what happens here. So here, you see we have a customer. Let's watch these here. They be around here? No, let's watch them here. A customer and a taxi. This will show us how these things change over time. Currently, there are no bookings, so they have their default state. Customer has a destination, has a location, has a name, and taxi is not driving, is nowhere right now, and they don't have a passenger. So the customer is booking a taxi. Let's go in. Now this is the book method. We want the taxi to come to the location of the customer first. Customer is currently at Kreuzberg. We want the taxi to navigate to the customer's location. All right, now we're in the taxi's navigate to method. And currently the taxi is not driving. First, it should start driving, right? This driving equals true. Then you update the location, you start the driving and take some time. You are at your destination. Taxi's location is currently empty. It's an empty string, but the destination is Kreuzberg. And now taxi, see it here, updated live. Taxi is still driving and taxi is in Kreuzberg. And now we need the taxi to stop driving. This driving equals false. Look at here, it's going to update and it's going to be false. Driving equals false. All right, the taxi is here. The taxi is in Kreuzberg. It's not driving anymore. It still doesn't have any passengers. The customer is entering the taxi. And what this means is taxi.passenger updates to the customer. See here, the passenger is currently null in taxi. And after I execute this line, taxi.passenger is a passenger. Perfect. I am in the taxi. Next up, I need to navigate to the destination. Again, the taxi currently is not driving. It should start driving. I'm now skipping this line. Driving is true. The location is Kreuzberg. It should be my destination. What is destination? It's Mitte. So the location is Mitte right now. And I'm still driving. I need to stop driving so that the passenger can get off. And I'm not driving anymore. Now, the passenger was in Kreuzberg, but the taxi is in Mitte right now. There is a, here, the taxi is in Mitte right now. There's a discrepancy here, and we solve it by updating the location of the passenger to the location of the taxi. And then, since the passenger, the customer, is at their destination is empty. And then they leave the taxi. What does that mean? Taxi's passenger becomes null. That's it. And now in our final state, the customer is at Mitte. The taxi is not driving and their location is Mitte. And the passenger is null. They don't have any passengers. Okay? That is all. That is basically all. If we want, we can take portions of this book method out so that it's a little bit easier to reason. Because navigating to the destination, entering a taxi and leaving a taxi is not actually part of the booking action. So what we do is we first book the taxi, and then taxi navigates to the, maybe we can say taxi navigation to the customer's location is happening in the booking. But then you can take all of these out and you can say customer books a taxi, the taxi comes. Customer enters the taxi, taxi navigates to the customer's destination, customer's location is updated, and customer leaves the taxi. Now, taxi navigate to. This is interesting. See this line? This location changes to the destination. I don't like these lines here. I believe these lines don't belong here. I believe this story should be this long. Customer books a taxi, customer enters a taxi, the taxi navigates to the destination, and customer leaves the taxi. This is the natural flow. I'm just thinking naturally. This is the natural flow of a booking. Where does the customer's location update? It updates when the taxi navigates to a place. So that should be in the navigate to method. When the taxi is updating its own location, it should also update the customer's location. If that taxi has a passenger, if there's a passenger here, we should update the location of the passenger and clear the destination of the passenger. I think this looks a little bit better. A customer books a taxi, enters the taxi navigates to the customer's destination, and then the customer leaves the taxi. Isn't that great? And basically we made this operation a very coherent, stable operation. The taxi navigates from one location to the other one. And if there's a passenger in that taxi at that moment, it also updates the location of the passenger. The passenger's location also updates. It is equal to the taxi's location all the times. Do I make sense? I'm a little bit over time, but I will quickly convert this to their final forms. These are objects, and they are great. But what if I have another customer? Right now, what I have to do is I have to copy and paste this entire block, and I have to do customer 2. And that would mean I need to copy and paste the book, enter taxi, and leave taxi methods as well. And that's a terrible idea. You can already see it. It's a terrible idea. What should happen is there should be some templates of these items. And we should be able to, like a cookie cutter, basically, we should be able to create multiple copies of that template. So what we do here is we convert this into a structure called a class. A class is something like a class in biology, but not exactly. And what you do is, what it does is it allows you to create copies of itself with new identities. So since we're gonna have more than one taxi, let me start by converting this into a class. Class taxi, it's not driving. Its location is empty, doesn't have a passenger. The syntax is a little bit different. And then we don't have commas here. Yep. And then we do taxi is a new taxi. Okay, it's gonna have these defaults. Driving false, there's no location, there's no passenger in it. Let's do the same for the customer. Class customer. Now, the customer's name obviously would differ. So by default, they don't have a name. The customer's location might also differ. So by default, they don't have a location, and by default, they don't have a destination. Okay? But what happens is when we create this object, we should take a name, a location, and a destination. Maybe it doesn't even, the customer doesn't even have a destination. Maybe not even a location. We're gonna see. And then we do save the name and the location of the customer to our internal state. This will make sense in a second. Now I don't need these anymore because I already defined them here as parameters. Now let me also delete these commas. How do I create a customer? A customer is a new customer whose name is Armağan and whose location is Kreuzberg. All right. And then, for example, for booking, maybe there you need a destination. Maybe there you need a location and a destination. Maybe that makes some sense. We book a taxi from here to here. Maybe that makes some sense. So what if I remove this one? When you create a customer in Uber, you don't always write your location. Even though you give location permission, it only asks you for your email and so on. So let's just say it's our name. And the location is also undefined right now. It's an empty string. And when we're booking a taxi, we say from Kreuzberg to Mitte. See, this looks even better. This sounds very natural. Very, very natural. Book a taxi from Kreuzberg to Mitte. Sounds great. And then we would have from and to as parameters here. And here we would update this location is from and this destination is to. And then taxi navigates to our location. This sounds much better. Let's see if everything works. Let's launch the program. And now customer is in Mitte. The taxi is in Mitte. It has stopped driving. It had a passenger, and I'm leaving the taxi right now. Doesn't have a passenger anymore. Worked great. Perfect. Cool. Cool. That's not so terrible, right? Let's take the taxi declaration here. We have a new taxi, we have a new customer. The customer books a taxi from Kreuzberg to Mitte. The customer enters the taxi navigates to customer destination, and the customer leaves the taxi. This is object-oriented programming with JavaScript. There are 2 words that I'm going to add to this code to make it proper JavaScript, and those are the types of these variables. They're constants. I'm not going to go into the details of that because you can find a ton of literature on internet for all of these syntaxes here. Again, the goal of these lectures are not to teach you the syntax. The goal of these lectures is to teach you the thinking behind object-oriented programming and more. And this is how we design our programs. Customer books a taxi from Kreuzberg to Mitte. Customer enters the taxi navigates to the customer's destination, and then the customer leaves the taxi. Now, this is so good. We could even simplify this further. I don't know if this would make sense in our application, but we could just have another function or the same function navigate to without this parameter. Why do we pass that parameter to the navigate to, because the taxi already has the passenger. The taxi knows the passenger, and therefore the taxi knows about the passenger's destination. Why do we need to tell them passenger's destination again? We don't. If the passenger wants to go somewhere else, they should change their destination. So what we can do here, in fact, this is where it gets a little bit tricky, where it gets a little bit ugly. But we can say, if we have a passenger, this location is this passenger's destination, and else, if we don't have a passenger, this location is destination. There are multiple ways of writing this. You might want to check if destination is there, because a passenger might need to override that destination, and so on and so forth. The use cases could be really different here. You might want to check if there is no destination and there's a passenger, then navigate to the passenger's destination. It gets uglier and uglier. But this is a very simple implementation. If there is a passenger, take the destination of the passenger. If there are no passengers, just directly go to the destination. Which means if there is a passenger inside, you cannot navigate the taxi to another place, which is also kind of, it might make sense. The taxi, if it has a passenger, can only navigate to the passenger's destination. If there are certain problems with that destination, the passenger has to update their destination first. The taxi cannot navigate to a random destination on its own. And frankly, it looks ugly here when we say navigate to and don't give it a parameter. So I'm just going to call this navigate. We're improving our design. Even here, navigate. We're improving our design. Let's see if this still works. And this is what you should all be doing. Improve your design and make it simple and foolproof. Here, the customer's location is Mita, destination is empty, taxi is not driving anymore, the location is Mita, and there's a passenger, and now there are no passengers, and it still works. Amazing. All right. This code is very simple, and it's modeling an interaction between a customer and a taxi. This is object-oriented programming in JavaScript, and this is the foundation of all of our code, all of our software. This is how we're going to start writing our Uber clone, basically. Probably none of these classes will be here. Probably none of these functions, none of these methods will be here. We're going to change them over and over again. That is the essence of programming. Everything will change. Everything can change. So you should be ready for it. You should be able to rewrite your application really fast. And you should be able to adapt to changing requirements from the business. So far, we have this 54 lines, 50 lines of code. We're going to start with this 50 lines, and then we're going to improve it later in the series. All right, I hope you like this. I hope you like this very short, by our standards, very short lecture on object-oriented programming. I am still over time. I'm over time by like 20 minutes, but maybe we talked about the fire for 20 minutes. I don't know. I hope you enjoyed it. If you like this video, I don't do this for my channel, but I'm going to do it for Coyotiv's channel. If you like this video, give a thumbs up, give us a like, hit the subscribe button, and hit the bell button so that you will be notified of all the future streams like this. We hope to do this every week, or at worst every 2 weeks. And next we're going to be building a couple of more classes on top and a couple of more interactions on top, so that we could identify one whole journey that has booking history and so on. So the future is bright, and the future is hopeful. And I hope we're going to be able to contribute to your understanding of object-oriented programming and maybe to a new career. If you'd like to change your career and become a software engineer, that's what we help with. So the link is in the bio. Check Coyotiv School of Software Engineering, coyotiv.com, and you can see our courses there, and you can sign up for whatever course suits your fancy. Thank you, Alina. All right, this is the end of our stream. It was very lovely for me. We did this for the first time, and I'm honored to have all of you here with me. It was a little bit eventful. The building literally caught fire, and we had to evacuate for about 30-35 minutes. But you know, when the neighborhood is burning, the teacher is teaching. So I was here for doing this class with you, and I loved it. I hope you also enjoyed it. And yeah, I will see you next time. Bye-bye.